In this video, we'll be talking about ultrasonic thickness sensing. In ultrasonic thickness sensing, what we're trying to do is measure the thickness of a material. Now, sometimes we can do that directly using some calipers or a ruler or something like that, but we can't always. If we've got a big sheet of metal or something like that, and we want to measure the thickness in the middle of it, well, it becomes a lot more troublesome to do so. And so what we can use is an ultrasonic thickness measuring device like this one here. Basically what it does is it sends out an ultrasonic pulse and receives how long it takes for that pulse to return. But rather than sending it through the air like we had previously with our ultrasonic rangefinders, it's sending that pulse through a material and waiting for it to hit the end of the material and bounce back again and be received by the device. We can use this for various forms of condition assessment. Like if we're trying to work out how thick something is, it might be wearing down over time. It might be corroding over time, and so some of that material is lost over time. One place this could be used is on a water tank, for example, when we're looking at the thickness of the wall of the water tank. The time taken to for that pulse to go and be bounced back again and received again is directly proportional to the thickness of that material. And these can be used with a wide range of different things, from plastics to metals to ceramics as well. Now, one thing we should note is we need to set up in our device what material that we're using it with, because different materials will have a different sound propagation rate. And so you see in that table there, the propagation speed of air is about 343 meters per second at our standard temperature and pressure. But we see lots of materials there that have very different and divergent propagation rates. So typically within our setup of this, it allows us to choose what material that we're dealing with. We also need to provide some ultrasonic gel to it. Just like in ultrasounds, when people are having a baby and they're looking at the baby, we put the ultrasonic gel in to help it couple to the surface that we're trying to measure on. So just a little bit of gel there. Now I've got here a sheet of aluminium. So currently it's set up for aluminium. And what we do is if we put this sensor on the aluminium, this aluminium should be about 1.6 millimeters thick, and when we've measured it, we've found it's 1.53. So it's quite close to that. I'll do another measurement at a different spot. And that one's pretty similar, 1.512. So you can see, imagine this was a whole side of a water tank. We could, without cutting in and taking a sample out of it, we could quickly run our probe over and touch a number of points and work out how thick these are, and maybe whether some remediation is required or something like that, or whether it's perfectly within the specifications of design. Now these can work up to a range of about 30 centimeters or so. So depending on what we're trying to measure, whether it's metal or whether it's ceramics and things like that, we can actually measure to a reasonable depth.